Good morning, students. In the last class, I explained what is inverse of a matrix, adjoint of a matrix, even what is a characteristic equation and its roots are a eigenvalue of a matrix, and also I have verified a Cayley-Hamilton theorem with a statement. Now, let us switch over to a next chapter called a binomial theorem. Binomial theorem. It is a third chapter in algebra. See, in school level you are aware of combinations and permutations. Okay, in school level combinations and permutations, and you also remember what is NCR and NPR. NPR means a permutation related, NCR is a combination related. Before going to binomial theorem, let us define what is NCR. What is NCR? NCR. You might have heard about NCR. This is n number of objects. N number of objects arranged at R at a time. Arranged in R at a time is called NCR. N number of objects. Okay, n number of objects R at a time is called NCR. N number of objects arranged R at a time is called NCR. NCR is equal to n factorial divided by R factorial into n minus R factorial. So, NCR is equal to n factorial divided by R factorial into n minus R factorial. You see, factorial, in some cases we are used this notation, in some other cases we used this notation. Either we can use this or this for a factorial sign. Next, see, n factorial means n into n minus 1 into n minus 2 into etc. up to 3 to 1. For example, let us go for one example. Let us factorial 5 is equal to 5 into 5 minus 1, 5 minus 2, etc. up to 2 1. It becomes 5 4 3 2 1, that is equal to 3 2s are 6 4s are 24 into 5 is 120. So, factorial 5 is equal to 120. This is a way of finding the value of factorial. Similarly, we can find, let us factorial 7. Factorial 7 is 7 into, okay, 6 into 5 into 4 into 2 into 1. See, n into n minus 1 into n minus 2 into n minus 3 etc. up to 3 to 1, we can find the value of the factorial 7. So, NCR means n number of objects arranged in R at a time is NCR. NCR is equal to n factorial divided by R factorial into n minus R factorial. Similarly, n factorial means n into n minus 1 into n minus 2 etc. up to 3 to 1. See, for example, factorial 5 is 5 into 5 minus 1 5 etc. to 1. Finally, it becomes 5 into 5 minus 1 is 4, 5 minus 2 is 3, similarly 5 minus 1 is 2 and 1. So, it becomes 120. Similarly, you can find the value of factorial 7 in the similar way. Next, let us switch over to a binomial theorem. See, the algebraic expression containing two terms, connected by a relation plus or minus is called binomial expression. Means the algebraic expression of containing two terms connected by a plus or minus sign is called binomial expression. For example, x plus a or even x minus a. This is called the first term, this is called the second term. This is called the first term, this is called the second term. So, algebraic expression containing two terms by a relation plus or a minus sign is called binomial expression. Example is either x plus a or x minus a, where x is a first term, whereas a is a second term, whereas this is there now, it is a plus or minus sign with a relation plus or a minus sign. So, algebraic expression of containing two terms by a plus or minus sign is called binomial expression. Next, the expression for the algebraic expression for x plus a whole to the power of n, algebraic expression for x plus a whole to the power of n for any value of n, for any index n, is called binomial theorem. The algebraic expression for x plus a whole to the power of n for any value of index n is called binomial theorem. So, algebraic expression for x plus a whole to the power of n for any index n is called a binomial theorem. Next, see, we are all familiar with algebraic formulas like x plus a whole squared or x minus b whole or x minus a whole squared or simply a plus b or a minus b whole squared or a plus b or a minus b whole cube. We are familiar. For example, x plus a power to the 1 is equal to x plus a itself. X plus a to the power 1 is equal to x plus a itself. Similarly, x plus a whole square is equal to, it is like a plus b whole square, x squared plus 2ax plus a square. Similarly, x plus a whole cube is equal to x cube plus 3x squared a plus 3a squared x plus a cube. This is the expansion of a plus b whole cube in the form. Similarly, if a power of x plus a goes on increases like x plus a whole to the power of 4 or x plus a whole to the power of 5, if it goes on increases, see, these algebraic formulas are not easy to expand these expressions like x plus a whole power 4 or x plus a whole to the power of 5. In such a case, binomial theorem will come to play very important role to expand this type of an expressions. So, up to x plus a whole cube we can easily expand by using algebraic formulas like a plus b whole squared or a plus b whole cube, like that. But as the power of this x plus a term goes on increases, for example, x plus a whole to the power of n, it is not easy to expand using these formulas. In such a case, we have to go for a theorem called binomial theorem. Now, binomial theorem statement is the expression for x plus a whole to the power of n for n is an integer, or a positive integer is equal to x plus whole power n is equal to x to the power of n plus nc1 into x to the power of n minus 1 into a power 1 plus nc2 x to the power of n minus 2 into a power 2 plus nc3 x to the power of n minus 3 into a power 3, etc. up to n terms. So, this type of an expression or a expression for x plus a whole to the power of n for a positive integer is called a binomial theorem. Or a statement for a binomial theorem. Actually, here x to the power of n, addition to the x to the power of n, we have nc0 into a to the power of 0, NC0 into a power 0, but NC0 value is 1 and a power 0 value is also 1, so that it becomes only x to the power of n, only x to the power of n, and also actually the last term in the expansion is a to the power of n, a to the power of n. The first term is x power n, that is first term whole to the power of n, and the last term is this term whole to the power of n, that is a to the power of n, a to the power of n. This is the expansion of a binomial theorem, where this NC0, NC1, NC2, NC3 etc. are called binomial coefficients. They are called binomial coefficients, NC0, NC1, NC2, NC3 etc. are called binomial coefficients, whereas NC0 value is 1, NC1 value is n only, and NC2 value is n into n minus 1 by 2 factorial. Similarly, NC3 value is n into n minus 1 into n minus 2 divided by 3 factorial, and so on. Therefore, finally it ends with NCR is equal to n factorial divided by r factorial into n minus r factorial. This is NC1, NC0, NC1, NC2, NC3, NC4. Finally, it ends with a NCR, that is equal to n factorial divided by r factorial into n minus r factorial, where these are all called binomial coefficients. Let us solve one problem on NCR. For example, 5C2. In this case, 5 is n, 2 is r. 5 is n, 2 is r. So it becomes n factorial divided by r factorial into n minus r factorial, that is equal to n. What is n? 5. 5 is the n value. So 5 factorial divided by r value is 2 factorial into n minus r, that is 5 minus 2 factorial. 5 factorial means 5 factorial divided by 2 factorial into 3 factorial. Now 5 factorial means 5 into 4 into 3 into 2 into 1. 2 into 1 divided by 2 factorial is 2 into 1 into 3 factorial is 3 into 2 into 1. So this 3 into 2 into 1, this 3 into 2 into 1 get cancels. This is 5 for the 20 by 2 is equal to 10. So 5C2 value is 10. So 5 objects combined 2 at a time, or 2 at a time is called 5C2. Its value is 10 factorial. Similarly, we can find the value for different combination of objects. Let us expand few problems using binomial theorem. Let us actually x plus a whole to the power of n is equal to x power n plus nc1 x to the power of n minus a power 1 plus nc2 x to the power of n minus 2 into a power 2 nc3 x to the power of n minus 3 into a power 3 etc. up to a last term. Okay, actually by observing this statement we can say one or two features of the binomial theorem. What is that feature means? Suppose the power is n, the total number of terms is equal to n plus 1 means the total number of terms terms in the expansion x plus a whole to the power of n is n plus 1. Means suppose the power is 10, therefore the terms are 10 plus 1, that is equal to 11. If the power is 10, we have to get a 10 plus 1 is equal to 11 terms in the expansion. Let it be. The total number of terms in the expansion is n plus 1. And just you observe this x powers. See, this is n minus 1, n minus 2, n minus 3. Means power of x. So, powers of x goes on decreases by 1. See, n minus 1, n minus 2, n minus 3, n minus 4, etc. And the power of x goes on decreases by 1, whereas you observe the a value. Actually a power 0. A power 0, a power 1, a power 2, a power 3, a power 4, etc. Means the power of a goes on increases by 1. So, power of a is increases by 1. X power is decreased by 1, whereas a power is increased by 1. So, total number of terms in the expansion is n plus 1. The power of x goes on decreases by 1 and power of a goes on increases by 1, and also there is a term called the general term. General term in expansion is, that is TR that is equal to NCR x to the power of n minus r into a power r. This is called the general term in the expansion. So, general term TR is equal to NCR x to the power of n minus r into a power r. It is also actually r plus 1th term. TR plus 1 is equal to NCR x power n minus r into a power. Using this term, using the general term, we can find any term in the expansion directly. Using the term, we can find any term in the expansion directly. Like, for example, if just I will give an example, like x squared plus 3 by x all to the power of n, here the power is n, therefore the total terms are 9 plus 1, that is equal to 10. If you expand this term by using binomial expansion, the total number of terms in the expansion are 9 plus 1, that is equal to 10. 10 means you expand that, you are using 1, 2, 3, 4 up to 10 terms. But using this general term, we can directly find out a 4th term, 5th term, or a 6th term. What is the direct term? Or what is the term independent of x? Means if you expand that problem, we are getting 10 terms. Out of 10 terms, x value may be there or may not be there in a particular term. That term also we can find directly by using a general term or a coefficients of some values. See, so for example, one of the term is x power 4, 234 into x power 4. We can directly find which is the coefficient of x power 4 in the term. That is the advantage of this general term. TR plus 1 is equal to NCR x power n minus r into a power r. Actually, these are the important features of the binomial expansion. Let us expand one expression. Expand x squared plus 3 by x, expand x squared plus 3 by x all to the power of 4, Here n value is 4, x value is x squared by x squared, and a value is 3 by x. You expand this. X power n means x power n is, here x is x squared, so x squared to the power of n. This is the first term. N means actually what? 4. So x squared to the power of 4 plus nc1, 4c1 x to the power of n minus 1. So x squared to the power of n is 4 minus 1 into a power 1. What is a? 3 by x to the power of 1. This is the second term. Next, plus 4c2 into x squared into n minus 2, 4 minus 2 into what is a 3 by x whole to the power of 1, 2, 2 plus 4c3 plus 4c3 x squared to the power of 4 minus 3 x squared to the power of 4 minus 3 into 3 by x whole to the power of 3 by x whole to the power of 3 plus 4c4 x squared to the power of 4 minus 4 into 3 by x whole to the power of 4. See, what I told in the previous feature is, if number of terms in the expansion is n plus 1, suppose the power is 4, the total number of terms should be 5. Total number of terms should be 5. See, 1, 2, 3, 4, 5. 4. If the power is 4, the total terms is 5. Total terms is 5. Now you simplify. X squared to the power is x power 8 plus, actually 4c1 value is 4 itself, because nc1 is n itself, nc1 4 into x squared to the power of 4 minus 1 is 3, so x to the power of 6 into 3 by x. Next 4c2 value is 6, or we can directly find out 4c2 is equal to 4 factorial divided by 2 factorial into 4 minus 2 factorial, that is equal to 4 into 3 into 2 into 1 divided by 2 into 1 into 2 into 1. Get cancels, 3 2s are 6. So 4c2 value is 6 into x to the power of 4 x squared whole squared, it is x power 4 into 3 squared by x squared, 3 squared divided by x squared plus 4c3 value is 4 itself. 4c3 value is 4 into x squared to the power of 1 is x squared itself into 3 cube divided by x cube plus 4c4 n value is 1. See, n value is 1 itself, therefore it becomes 1, and x squared to the power of 4 minus 4 is 0. So anything to the power of 0 is also 1. So finally it ends with 3 to the power of 4 by x to the power of 4. See, this is the basic formula or a basic theorem in binomial theorem. According to theorem, where expand the term like x squared plus 3 by x whole to the power of 4 is x to the power of 8 plus some more simplification, x power 8, this is 1x get cancels, so 4 3s are 12 x power 5 plus 3 squared is 9, so 9 into 4 is 54, see x power 4 divided by x squared is x squared plus 3 cube is 21, 3 cube is 3 into 3 into 3, okay, 3 into 3 is 9, 9 into 3 is 27, 27 into 4, 27 into 4 is equal to, so 108, so it becomes 54 plus 4 into 3 cube is 108, see 1 x squared get cancels, 108 divided by x plus 3 power 4 is 3 into 3 into 3 into 3 into, that is equal to 9 9s are 81 divided by x power 4. This is the expansion of x squared plus 3 by x whole power 4, because this term we can't able to expand by using any algebraic formulas like x a plus b whole to the power of 4. Even if you expand, it becomes very difficult. Whereas if you use a binomial theorem, we can easily expand this term. Of course, it is 4. Suppose the term is 5 or a 6 or a 7, again it is complicated to expand. Let it be. But binomial, using binomial expansion, we can easily find out the expression of these terms. So x squared plus 3 by x whole to the power of 4 is x power 8 plus 12 into x power 5 plus 54 x squared plus 108 into 1 over x plus 81 by x to the power of 4. let us expand one more term. Let us expand one more term. X squared minus 1 over x cube all to the power of 5. All to the power of 5. Actually here x term is what? X squared. X term is x squared itself, and a term is minus 1 over x cube. A term is minus 1 over x cube, and n is equal to 5. And n is equal to 5. N is equal to 5. Now, according to binomial expansion, x power n, that is x squared to the power of n is 5. How many terms in the expansion here? If x squared minus 1 over x cube whole to the power of 5, how many terms in the expansion? There are 5 plus 5 plus 1, that is equal to 6 terms. Next, plus nc1 is 5c1 into x to the power of n minus 1 x squared to the power of 5 minus 1 into minus 1 over x cube to the power of 1 plus 5c2 into x squared to the power of 5 minus 2 into minus 1 over x cube to the power of 2 plus 5c3 x squared to the power of 5 minus 3 into minus 1 over x cube to the power of 3 plus 5c4 x squared to the power of 5 minus 4 minus 1 over x cube to the power of 4 plus that is the last term is 5c5 value is 1, x squared to the power of 5 minus 5, that is value is also 1. Finally, directly we can write last term is minus 1 over x cube to the power of 5. See, just to check how many terms in the expansion, 1, 2, 3, 4, 5, 6. If the power is 5, the number of terms is 5 plus 1, that is equal to 6. You simplify. Let us simplify. X squared to the power of 5 is x to the power of 10 plus 5c1 is 5, x squared to the power of 4 is x to the power of 8. Here minus 1 by whole cube to the power of 1 is minus 1 over x cube itself, plus 5c2 value is 10. 5c2 value is 10. X squared to the power of 3 is x to the power of 6, minus 1 whole squared is plus, or minus whole squared is plus 1 over x power 6. 1 over x power 6 plus 5c3 value is also 10. 5c3 value is also 10. X squared to the power of 2 is x power 4. Next, minus 1 whole cube is minus itself, minus 1 over x to the power of 9, minus 1 over x to the power of 9 plus 5c4 value is 5 into x squared to the power of 1 is x squared into minus all to the power of 4 is plus, so it becomes x to the power of 12. Finally, minus 1 all to the power of 5 is plus minus 1 whole to the power of minus 1 over x to the power of 15, So, it becomes x power 10 plus into minus is minus, see x cube it cancels, finally it becomes 5x to the power of 5 minus 5x to the power of 5. See here x power 6 get cancels, plus 10 minus into plus is minus 10 into this is x power 4, the x power 9. So, 1 over x to the power of 5 remains, plus here also plus see x squared 2 get cancels. So, x power 10. So, 5 into 1 over x to the power of 10, finally minus 1 over x to the power of 15. This is expansion of x squared minus 1 over x cube all to the power of 5, all to the power of 5. A small break. Okay, similarly, actually we are expand the algebraic terms. Similarly, we can numerical terms also we can expand by using binomial expansion. Let us expand or show that root 3 plus 1 all to the power of 4 plus root 3 minus 1 all to the power of 4 is equal to 56. See, Using binomial expansion, we can show that root 3 plus 1 whole power 4 plus root 3 minus 1 whole to the power of 4 is equal to 56. Let us expand first root 3 plus 1 whole to the power of 4. Root 3 plus 1 whole to the power of 4. Here what is x? X is equal to root 3, a is equal to 1 and n is equal to 4. Let us expand now according to binomial expansion. Root 3 plus 1 whole to the power of 4 is equal to x to the power of n, means root 3 to the power of 4 plus nc1 is 4c1 into x to the power of n minus 1, that is 4 minus 1 into a is 1 to the power of 1 plus 4c2 into root 3 to the power of 4 minus 2 into 1 to the power of 2 plus 4c3 root 3 to the power of 4 minus 3 into 1 power 3 plus 4c4 into root 3 to the power of 4 minus 4 into a power 4. This is an expansion of root 3 plus 1 whole to the power of 4 using a binomial theorem. Let us simplify. Root 3 to the power of 4 is root 3 into root 3 into root 3, 4 times root 3, that becomes root 3 into root 3 is 3 and 3 into 3 is 9 plus 4c1 is 4, root 3 to the power of 3, root 3 power 3 is, see, root 3 power 3 is equal to root 3 into root 3 into root 3. So, root 3 into root 3 is 3, 3 into root 3 is 3 root 3. So, 3 root 3 into 1 is, let it be, plus 4c2 value is 6, root 3 whole square. Root 3 whole square is root and square get cancelled, we get only 3 plus 4c3 value is 4 itself, 4c3 value is 4, root 3 to the power of 4 minus 1 is root 3 itself into 1 plus this value is 1, this value is also 1. So, 1 to the power of 4 is 1 itself. Now, 9 plus 18 plus 1 is equal to 28, 4 3s are 12, 12 root 3 plus 4 root 3 is 16 root 3. Now, root 3 plus 1 whole to the power of 4 is equal to 28 plus 16 root 3. Similarly we get root 3 minus 1 whole to the power of 4 is equal to 28 minus 16 root 3. 28 minus 16 root 3. Even if we expand, we get the same only. But the problem is what? Root 3 plus 1 whole to the power of 4 plus root 3 minus 1 whole to the power of 4 is equal to 56. Now, root 3 plus 1 whole to the power of 4 plus root 3 minus 1 whole to the power of 4 is equal to, what is root 3 plus 1 whole power 4? 28 plus 16 root 3 plus root 3 minus 1 whole power 4 is 28 minus 16 root 3, 16 root 3 minus plus 16 root 3 get cancels. So, 28 plus 28 is equal to 56. It is a numerical expansion. So, see, manually we can't able to find out easily root 3 plus 1 whole to the power of 4, but using a binomial theorem we can easily find out the value of root 3 plus 1 whole to the power of 4. Actually, in examination for a 2 marks, the problem is like, I will say by using same only, I can explain. See, they only show same root 3 plus 1 whole to the power of 4 plus root 3 minus whole to the power of 56, the same I only explain. See, problem, if root 3 plus 1 whole to the power of 4 is, root 3 plus 1 whole to the power of 4 is 28 plus 16 root 3, root 3 plus 1 whole to the power of 4 is 28 plus 16 root 3, find the value of this one, find the value of, so root 3 plus 1 whole power 4 plus root 3 minus 1 whole to the power of 4. They only give the value of root 3 plus 1 whole to the power of 4, but what we have to do? We have to change this one into root 3 minus 1 whole to the power of 4. See, just a minute. see, they have only given the value root 3 plus 1 whole power 4 is 28 plus 16 root 3. Therefore, root 3 minus 1 whole to the power of 4 is what? 28 minus 16 root 3. So, you add this value plus this value, finally it ends with 56. It is for a 2 marks problem, 2 marks problem. They only either they may give root 3 plus 1 whole to the power of 4 or a root 3 minus 1 whole to the power of 4. Finally, they ask root 3 plus 1 whole power something plus root 3 minus 1 whole to the power of something. Similar problems they may ask for 2 marks, for 2 marks. See, this is an expansion of terms by using binomial theorem, binomial theorem. Next. So, next type of a problem is, next type of a problems are find directly. Actually here we are completely expand the expressions, but I already told by using a general term we can find out directly the 6th term, 7th term, 8th term, even 4th term, okay. So, that type of a problem, find 6th term in the expansion, find 6th term in the expansion, find 6th term in the expansion, x by 2 minus 2 by x, x by 2 minus 2 by x all to the power of 9, all to the power of 9, x by 2 minus 2 by x all to the power of 9. Now, this is x value, this is x value, this is a value and this is n value. Now, what is general term? T r plus 1 is equal to NCR x to the power of n minus r into a to the power of r. This is called the general term in the expansion. Now, see what we want 6th term, that is T6 we want, see here the general term is T r plus 1, therefore it becomes what? If it becomes a 6, it should be a 5 plus 1. Therefore, to find out a 6th term, what is r value? R value is 5 only. To find out the 6th term, the r value is 5 or a previous term, previous value. Suppose if you want a 7th term, the r value is 6. If you want to find the 10th term, the r value is 9, like that. Now, let us go for an expansion. What is the r value now? R is equal to 5. R is equal to 5. X is equal to what? X by 2. A is equal to minus 2 by x and n is equal to 9. N is equal to 9. Now, T r plus 1 is equal to T. What is r value? 5 plus 1 is equal to NCR. What is n? 9C. What is r? 5. 9C 5 into what is x power n minus r? That is x by 2 to the power of 9 minus 5. N value is 9. R value is 5 into a. What is a? Minus 2 by x to the power of 5. 9C5 as it is into x by 2 whole to the power of 9 minus 5 is 4. This is minus 2 to the power of 5 divided by x to the power of 5. Or even this one also we can directly write x power 4 divided by 2 power 4 also, 2 power 4. 9C5 x power 4 divided by 2 power 4 into, see minus 2 power 5 is minus multiplied by 5 times is again a minus. So, it becomes minus 2 to the power of 5 divided by x power 5. Now, see x power 4 get cancels and 2 power 4 get cancels. So, finally, we get minus 9c, this minus is here, minus 9c5 into 2 by x. So, minus 9c5 into 2 by x. even we can find the value of 9c5, or you let it be as 9c5. So, it becomes minus of 9c5 into 2 to the power of x. This is the which term? This is the sixth term in the expansion. Sixth term in the expansion. Even if you want, this is an expression. No, you expand by using binomial expression or a binomial theorem. Finally, you see this is the power 9. Therefore, how many terms we get? We get 10 terms. Definitely, the sixth term is minus 9c5 into 2 to the power of 5. But without an expansion, we can easily find out sixth term in the expansion using general term in the expansion. That is the advantage of, that is the use of, that is the prominence of general term. So, using the general term directly we can find out the direct term, whichever the term is. Next problem. Find seventh term in the expansion. Find seventh term in the expansion. Find seventh term in the expansion. Ax plus b by x, ax plus b by x whole to the power of b by x whole to the power of 12. Whole to the power of 12. Directly we have to find seventh term in the expansion. Suppose we want to find the seventh term. What is the r value? R value is 6, x value is ax, a value is b by x, and n value is 12. Now you substitute t r plus 1. What is r value? 6 plus 1 is equal to n 12 c 6. What is x value? Ax to the power of 12 minus 6 into what is a? B divided by x to the power of r is 6. You simplify. 12c6, 8x to the power of, ax to the power of 12 minus 6 is 6 into b to the power of 6 divided by x to the power of 6. Next, 12c6 into, this is a to the power of 6 into x to the power of 6 into b to the power of 6 divided by x to the power of 6. Now, x power 6 get cancels, that is equal to 12c6 into a power 6 into b to the power of 6, or 12c6, so ab to the power of 6. This is the seventh term in the expansion. This is the seventh term in the expansion of ax plus b by x whole to the power of 12. You see, using this general term, we can easily find out a seventh term in the expansion without an expansion of by using a binomial theorem. It is very advantageous one. Okay, this is one type of problem in binomial theorem. Next. Next is middle term in the expansion. Middle term in the expansion. See, for example, x plus a whole to the power of 5, how many terms in the expansion? There are 6, 5 plus 1, that is equal to 6th terms in the expansion. Okay. Similarly, x plus a whole to the power of 6, how many terms? 6 plus 1, that is equal to 7 terms. Suppose 7, if it is a 6th term, means 1, 2, 3, 4, 5, 6. There are 6 terms. So, which is the middle term? See, 2, 2, 6. See, there are 2 middle terms in the x plus a whole to the power of 5 terms. Similarly, if it is 7, 1, 2, 3, 4, 5, 6, 7. Here the middle, you see 3, here 3, the middle term is what? 4. Means if it is x plus a whole to the power of 6, the number of terms are 7. Therefore, we get only one middle term. Suppose if it is x plus a whole to the power of 5, how many middle terms? There are 2 middle terms. Now let us conclude. If expression, the power of an expression is odd, we get 2 middle terms, The power of an expression is even, we get only 1 middle term, you see. Okay. So, expansion, the power of an expansion is odd, we get 2 middle terms. If the power of an expansion is even, we get only 1 middle term, one middle term. Actually, here if the power is even, n by 2 plus 1th term, one term means what is the n value here? What is the n value? 6. 6 by 2 is 3. 3 plus 1 is 4th is the middle term. Whereas if the power is odd, n plus 1 by 2th term, and n plus 3 by 2th term, n plus 1 by 2 and one more is n plus 3 by 2, See, this is for an odd, n plus 1 by 2th term and another is n plus 3 by 2th term. For example, here what is the odd number here? 5. So, 5 plus 1 is 6, 6 by 2 is 3 is the middle term and one more is 5 plus 3 is 8, 8 by 2 is 4th is the middle term. Means the power of an expansion is odd, we have 2 middle term, n plus 1 by 2th term and n plus 3 by 2th term, whereas if the power of an expansion is even, we get only 1 middle term, that is n by 2 plus 1th term, one term means, so power of the expansion is odd, we get 2 middle terms. If the power of expansion is even, we get only 1 middle term, Let us solve one problem. Find middle term in the expansion. X by y plus 2y whole to the power of 12. X by y plus 2y whole to the power of 12. Now, how many terms in the expansion? There are 12 plus 1, that is equal to 13 terms in the expansion. So, which is the middle term? Middle term is what? N by 2 plus 1th term, because it is here the power is even, so that we get only 1 middle term. What is the n value? 12 by 2 plus 1. So, 12 by 2 is 6, 6 plus 1 is 7th term. So, 7th term is the middle term. Now, we have to find out 7th term like a previous type. So, now 7 is the middle term, therefore, we have to find out T7 we have to find out. Now, you write a general term formula. So, 7 T r plus 1 is equal to NCR x to the power of n minus r into a power r. See which is the middle term? So, 7th term, therefore, what is the r value? R value is, to find out a 7th term, r is equal to 6. Now, T 6 plus 1 is equal to 12C6 into what is x value? X by y is the x value, okay. Xy to the power of 12 minus 6 into a value is 2y to the power of 6. You simplify. 12C6 x to the power x by y whole to the power of 6 into 2 to the power of 6 into y to the power of 6. 2y whole power 6 is 2 power 6 into y to the power of 6. So, 12C6 into x power 6 divided by y power 6 into 2 power 6 into y power 6. Now, y power 6 get cancels. So, what we get? 12C6 into x power 6 into 2 power 6, or we can simplify 12C6 and also even 2 power 6. What is 2 power 6? 2 into 2 into 2 into 2 into 2 into 2. 4, 4, 4, 64. So, 64, 12C6 into 64 x power 6, or we can find out even 12C6 also using NCR formula, n factorial divided by r factorial into n minus r factorial, or we can let it be, okay. Whether you write, even you find the, after finding a value, we can write the value, or we can simply write a 12C6, okay, nothing to worry. So, this is the way of finding the middle term in the expansion. If here the power is even, therefore we get only one middle term, Suppose the power is odd, how many middle terms we get? There are two middle terms, Next, find the middle term in the expansion. 2x minus 1 over x whole to the power of 10. 2x minus 1 over x whole to the power of, this is middle term problem, 2x minus 1 over x whole to the power of 10. See how many terms in the expansion? 10 plus 1, that is equal to 11. Which is the middle term? See, middle term is n by 2 plus 1th term. So, that is 10 by 2 plus 1. So, 10 by 2 is 5, 5 plus 1 is, we have to find out 6th term. 6th term is the middle term. For the 6th term, what is R value? R value is previous one, that is 5. That is equal, therefore, so R is equal to, for this particular case, R is equal to 5. Now, we have to find out 6th term in the expansion. You write general term, T R plus 1 is equal to NCR x to the power of n minus r into a to the power of r, T, what is R value? 5. 5 plus 1 is equal to 10C5. What is x value? 2x. Here x value is 2x, a value is 1 minus 1 over x, 2x whole to the power of 10 minus 5 into a minus 1 over x whole to the power of 5, So, 10C5, so 2x to the power of 5 into minus 1 whole power 5 is minus 1 over x power 5, So, 10C5, so 2 power 5 into x power 5 into minus 1 over x power 5. So, x power 5 get cancels. So, finally, it becomes 10C5 into 2 to the power of 5. 2 power 5 is 4 into 2. 16 2s are 32. So, finally, minus 32 into 10C5 is the middle term, okay. I will, this is about binomial expansion, what is binomial theorem and how to expand, and finally how to find the direct term or how to find the middle term in the expansion. Thank you. I will continue in the next class.